Hello again, it's Phil Story, a network detective from Australia. Today we're going to have our first look at the NetData flowchart. The underlying principle of the flowchart is very similar to the Wireshark TCP Trace. In part 1, I'd like to focus just the mechanical aspect of using the chart and all the various options. It's NetData, so we're visualizing IT performance. And the chart we're interested in today is the flowchart, and it's slaved to the packet timing chart, so we'll be looking at that too. These are the topics I'm going to cover in this video. And of course, as usual, using the format button, zooming in, right-clicking and hovering the cursor. I'm going to use the packet train PCAP file that we've seen before. Drop that on. Fast forward. I've jumped ahead to show you what NetData displays in the first instance for this PCAP. I've jumped forward again just so we don't have to see the time spent arranging these windows. And the first thing I want to do is view minimum round trip times, clients and servers, and that's a different way of getting to the dialog chart. And we get to the dialog chart with the round trip time. And what we see here is that this is a server-side capture and the client is 30 milliseconds round trip time away. Now I've positioned the packet timing chart and the flow chart on top of each other like this to show the slave mechanism. So when we zoom into one, let's say we do that, then the other one will match the time frame. Equally, if we zoom into the one on the top, the flow chart, the packet timing chart will match. While I'm here, I'll just diverge a little bit. In the last video, we looked at this red packet, which was a ACK leaving gap. Now I just locked that on. If you recall, I used a little spreadsheet to determine how big the gap was. Well, Bob Brownell of Measure IT, the owner and developer of NetData, saw that and thought NetData should be doing the work. And so in the last day, I've got a new version, and now the pop-up on that red packet says leaves a gap of 194. Now to be fair, if we hover on the green packet, that also says filled gap of 194, preceding fragment. That was there all the time. Now one more aspect of this slave business that I'd like to show is we'll leave the packet timing chart that size and we'll maximize the flow chart. So notice that the legend is in this small font. If I go back to the packet timing chart, I'll maximize that. Now I'll go back to the flow chart and just make some kind of change. I'll just zoom in a bit more. And now we see the size of the legend is larger to match the packet timing chart. So that's the hint. The legend size on the flowchart always matches the legend size on the packet timing chart. I'll just point this out before we come back to it later. On the flowchart, client packets and server packets can be on the chart at the same time. Now I've just zoomed out, I've turned off the client packets, I've turned off the round trip time markers, I've tried to make it as simple as I can, and I've zoomed all the way out. And what we can see is that the interesting behavior is in the middle. Before I get to that, one of the things we can do is hover on this line, and this line is the client receive window, and Alt-Z lock that on. And while we're at this scale, I'll just point out the little numbers that appear everywhere, and they mean various things. Zoom into this interesting area. This is where NetData's use of color and size and position all come into play. Let's begin at this scale and discuss what these big patterns are. Let's just zoom into this area. We'll zoom right in. We already know from the packet timing video there were 4 full-size data packets that didn't make it to the other side, and the final one did. Where on the packet timing chart it's a red square around the black square packet. On the flow chart, packets are basically vertical strips representing the sequence number height, and if I lock one of those on, the packets have got a red stripe attached to them. We saw them, the real receiver didn't. Because these packets didn't get through, and we got an ICMP saying they need to be reduced in size, then we have a purple packet now, so that's a retransmitted packet. There was a retransmitted little chunk that didn't get through, that was also lost beyond the monitor. There was another purple one that presumably did get through, and there was another little one that didn't get through, and finally that last one. And down the bottom we see the green area, bytes in flight, and at this point we have 4.6 segments in flight. This little red tick is a very useful indicator, and it's plotted on the bytes in flight line at the height of the bytes in flight when a packet got lost. So these 4 packets got lost when there was no bytes in flight, and this one got lost when there was 1 packet in flight. Now right click over on the right, we'll double the time, and then we'll zoom out to this. So what are some of these other numbers? Well, there's a little 3. The 3 on top is saying that there's 3 packets in. The little 1 is saying this is the first duplicate ACK. The light blue area, left and right edge of the selective ACK, is the data that is being selectively acknowledged. By implication, the data under that to the normal ACK line was not received. NetData is plotting that as a cross-hatched area for the data that was not received and a light blue area for the data that was received. So let's have a deeper look into this selective ACK area. So there's a selective ACK here which said we still haven't got this cross-hatched area. We did acknowledge this little blue zone, which is in response to this retransmitted data packet. We still haven't got that, and we still have got that. In response, the client sent this data retransmission, 1310 bytes, and then this one at the bottom. A selective ACK about this time acknowledged this data packet, so the blue area expands. So it's now left edge, right edge, left edge, right edge. There's also a little tiny extra data packet. At this time, a normal ACK, or in fact it's another selective ACK comes through. It says, right, I've now normally ACKing this level, so I got that, but my left edge, right edges are the same. I still haven't got this data. Sender retransmits 1, 2, 3 packets. There's a normal acknowledgement, another packet, and another one. And then normal ACK line, and normal ACK line. And at this point in time up here, we're fully back to normal. While I'm zoomed into this scale format window, I'll just mention that you can turn on push flag, replot, and what we get there is a little purple horizontal line attached to any packet that has a push flag. These 4 didn't, the last one did, that makes sense. And that little guy up there, he also does. And here's 2 little packets that also have the push flag attached. And while we're here, I should point out that the bytes in flight display down the bottom also adjusts to reflect selective ACK information. So it's saying that at this point in time, the blue area is data that has been selective ACK. This greeny crosshatch color is the data that has not been selective ACK. I'll go back to the packet timing chart, full time display, and I just want to point out at the bottom right corner is the packet count. Yesterday we were interested in this area. Now what I'd like to do is turn on client packet and go back to the display where client packets and server packets. And we notice the ACK line is blue for server packets, it's green for client packets. Furthermore, we have 2 sets of all the other numbers. So there's the client receive window, and here is the server receive window. So we can see them both at once. Because this chart just has 1 packet each way, there's not much bytes in flight different colors to see. But I can also, if I turn on data throughput rate, we get 2 throughput lines, one for the client and one for the server. The color code in the legend tells you what each one is, but it's pretty obvious that this purple one must be the client one because that's the one with lots of data at this particular point in time. We can turn on trip times. This is showing that you can make these charts pretty complex. I'll just point out the trip time scale is on the right hand side, and trip times, as you recall, are the little black packets. I'll go to the format control window again. I'll turn off the throughput, and what I'll do is in the trip times area here, I can change the color to be colored by MAC address. And when I do that and replot, now we can tell the difference between the trip times for the client and server, because one of them's green, and the one that's green is the one of this MAC address to that MAC address. But there is another way to separate the client and server trip times, and that is by using this reverse client sign, replot. And now what we see, the scale has slightly changed, and now there's a 0, and trip times that are below the 0 line, in other words negative, they're the client times, and trip times that are above 0, the positive, they're the server times. And the very last thing I want to show is gap fill times. We know that there was a green packet on here, which is a gap filling packet, and I'll turn off trip times just to clean up the chart again. Replot. Now there's one green marker that's associated with a gap filling packet, just to refresh your memory. A green packet is a packet that filled a gap, and this is what filling up the 194 bytes that was missing from over here. And therefore a green packet has a corresponding green gap filling time marker, and it's telling us that it took 5.9 seconds to fill the gap. We're still in the minus scale for client packets, so it's showing up as minus 6,000 on this scale, and that's why it's down the bottom. Another subtle aspect of these gap filling markers is that there's a dark square bordering the green, and that means that packet fully filled in the gap. If there was a large gap, and the first green packets would not have the border because they'd be partially filling the gap. And one final thing just to point out on here, just one of these other little subtle things that NetData adds to charts, is that because I hovered on this green packet, there's a little circle up there on the ACK line of the server packets saying that's the packet that acknowledged the green one. And so on that topic, one final thing, links to acknowledged data, replot. Like the packet timing chart, on the flowchart you can have these lines that link the data packets with the packets that ACK to them, and again a different color for the client and server side. Phew, there was a lot of stuff in there. There's my details. On the next video we'll look at using the flowchart to actually solve a real problem. Stay tuned.